Hi, algebra students. We're going to work on solving systems of inequalities today. So I'm going to share my screen and start the presentation. And these are kind of fun because you get to do some shading. And we haven't looked at inequalities in a little bit. So I'm going to start with some vocabulary. This needs to go in your journal on page 159. So pause the video, copy down the definitions. And then also, you might want to draw that little picture. So let's see if they give you, when you write down they're off to the side, maybe next to your definitions on that page, if you could draw a little picture of what the half planes look like. All right, welcome back. So we have a linear inequality in two variables. It says it describes a region of the coordinate plane that has a boundary line. See the graph below. Solutions of a linear inequality are the coordinates of the points that make the inequality true. So if you look, this has divided this region into two half planes. I have a shaded side and a non-shaded side, and this dotted line. The inequality that's graphed here is y is greater than x plus 1. And I have this point -3, 2. And it is just one solution of this inequality, and we're going to talk about that. So these two regions here are called half planes. All right, so we're going to jump to page 160 in our journal. We're going to look at some extra practice problems. So I'm going to grab my pen. Hopefully. There we go. And it says, tell whether the ordered pair is a solution of the inequality. So we have an ordered pair here. We have an x coordinate and a y coordinate. And I'm going to put these into the inequality in place of the x and y terms. So I'm putting -1 in for x. I am putting 2 in for y. And I want to know, is that less than or equal to 4? Because I'm checking to see if it's a solution. So I have -1 plus 2 times 2 is 4. And again, I'm still asking myself, is that less than or equal to 4? Well, let's see, -1 plus 4 is 3. And 3 is certainly less than or equal to 4. So I would say, yes, it's a solution. When you're checking these today, you are going to need to show your work just like I did there. All right, let's try another one. This time we have 2 for x and -2 for y. So the question is 5 times 2 plus a -2, right? That's going in for y. Is that less than 7? That's what I want to check. I don't know if you can see it on your screen, but I kind of have these bars that are in the way here, so I'm going to move this problem over. So 5 times 2 is 10, plus a -2 is the same as -2. Is that less than 7? Question mark. Well, let's see, 10 minus 2 is 8. 8 is not less than 7. And so my answer would be no, it is not a solution. All right, let's look at our next slide. Is that what we jumped to? Yeah. All right, so we get our chance to graph here. I'm going to erase our other notes from the previous slide here. All right, we are graphing y is less than 4. Now we had problems like this before when we had number lines. And it's the same idea, but the one thing I want to think of when I'm doing these is instead of thinking of it as an inequality, like y is less than 4, I can think of this as an equation. So y equals 4. All right, if I were to graph the line y equals 4, that would be a horizontal line passing through 4 on the y-axis. All right. If you remember back when we were graphing things on number lines, if we had something like x is less than 3 and we were drawing it on a number line, we would have an open circle at 3, and then we would shade things to the left in this case because it's less than, right? It's the same idea with these, except that now we're in the coordinate plane. So I know this needs to be a horizontal line, but since this is strictly less than, I'm going to draw my horizontal line as a dotted line. All right, so we have That's my line, y equals 4, right? And I draw it as a dotted line because there's no equal sign here. But then I have to figure out how can I show that I want all the solutions that are less than 4. Well, if you think of this boundary line, anything above this line is greater than 4. Anything below the line is less than 4. So I'm going to do some shading. So I'm going to grab a fatter pen, and I'm going to grab even a different color. And my solution is any number or ordered pair that is in this, and you can do a much better job of shading with colored pencils or your pencil today, is any point down in this region. All right, if you're not sure if you've graphed it correctly, you can always, I'm going to go back to my just regular pen here, and I'm going to pick some ordered pair. All right, let's pick the point, something easy to work with, like this point right here. So this point right here is the point 0, 0. Here's the point 0, 0. I'm going to erase, that looks horrible. And I erased lots of the green now, but that's okay. Let's go back to my pen. This is the point 0, comma 0. All right, now it's in my shaded region here, which means it should be a solution. So if I take my 0, 0 and I plug it in here, is 0 less than 4? Is that true? Yes, right? So I have shaded the correct side of the line. If I pick some point in the other side of the non-shaded region, like let's pick, I'll just go with blue. Let's say I pick this point here. Remember, I can pick anything. So let's do this point, which is the point -3, 5. Right? I want to know, does that work? All right, so this is my x coordinate, this is my y. My inequality only has y, so I'm going to plug in that 5. Is 5 less than 4? Is that true? And the answer is no. All right, so since this point is not in my shaded region, it's not a solution. So if you're not sure when you've drawn your line or shaded, if you've shaded the correct side, you can always pick a test point. One that's always easy to work with is 0, 0. All right, so I'm going to erase all this and get ready for our next example. All right, so next slide. Maybe. Is that the last? Let's see here. No. All right, this time we have extra practice problem number, whoa. Go back, go back, go back. It turned to crazy town there. Where were we? All right, we did that one. We did that one. All right, we're on 10. So we have x is less than or equal to 1. So I'm going to grab my pen. So the questions you're asking yourself today are, what kind of line is it? Is it dotted or solid? And which side do I shade? So this time I have x is less than or equal to -1. So a normal x equals -1 line would be a vertical line. And I'm going to do the same thing here. So all the inequality does to our line is, first of all, tell us is it dotted or solid? And then this indicates which side we need to shade. So I'm going to draw my vertical line, and this time it's a solid line because my solution can include anything on this line. And then values that are less than or equal to -1. Let's grab the fat pen. Anything less than or equal to -1 is going to be over on this side of that line, right? Less than is to the left. All right, so I'm going to go back to my pen. I'm going to pick a test point just to make sure I've shaded correctly. And again, remember that 0, 0 is super easy to work with. So the question is 0, 0 solution? Well, you should look. Is 0, 0 on the shaded side? Okay, no, it isn't. So if I plug 0, 0 into this equation, it should not be true. All right, so let's see. This time I'm just dealing with x, so I'm going to put 0 in there. Is 0 less than or equal to -1? And the answer is no. So we have shaded correctly because 0, 0 is not a solution. I need points that are in this side, or they could be points on the line. For example, if I pick this point here, the coordinates of that point are -1, 2. If I plug that in here, so my x coordinate's -1, is -1 less than or equal to -1? Yes, all right, it's equal to it. So it is a solution, and that's what I had. I could have picked something else, like this is -3, 0. Let's see if that works. So I'm plugging in -3 for x. Is -3 less than or equal to -1? Yes, okay. So any point on the line or to the left of the line is a solution. All right, let's try another one. I'm going to erase all these annotations. And we're going to look at our next slide. Come on. All right, so this is extra practice problem number 13. So this time we finally get a little more excitement. It's not a vertical line or horizontal line. This time we have both. So you need to think to yourself, how would I graph y equals 3x plus 1? Because that's the corresponding line that's associated with this inequality. Well, we have a slope of 3 or 3 over 1, right? This is in y equals mx plus b form. We have a y-intercept of 1. And so I'm going to go ahead and graph that. Now, what I need to notice is that this is just less than. There's no equal. So I need to notice that when I draw my boundary line, it needs to be a dotted line because the solution does not include the boundary line in this case. So my y-intercept is 1. I put a dot there. My slope is 3 or 3 over 1, so I go up 3 squares and over 1 square. And remember, you can get multiple points, except I only went 2 there, so good thing I was looking. Let's go back to the pen. Okay, from here, go up 3 squares, 1, 2, 3 over 1. There we go. And I can't fit any more up that way, so I'm going to go down this way. All right, we said this needs to be a dotted line. So I'm going to do my best to draw a dotted line here. Okay, so there's my line. And you'll have a trusty ruler to be able to do this on your own. And now I have to decide. It says I need to shade values that are less than this. So I like to think of less than as being below, but sometimes it's a little hard to tell. Okay, so I think my solutions are over here, which is below the line. This is above. It's slightly tilted, so these values would be above. Down here is below. So if I look, my friend, the point 0, 0 is over here below the line. So if 0, 0 works in this case, that should be the side I shade. So I'm going to go ahead and put a dot at 0, 0. That's right here. And I think my solutions are over here below the line. So remember, we can test this point in the inequality and see if it's true. So the question is 0 less than 3 times 0 plus 1? So I'm going to simplify that. Is 0 less than 3 times 0, 0? 0 plus 1 is 1. Is 0 less than 1? Yes. All right, so my solution is this side. So I'm going to grab my fatter pen and I should shade everything to this side. Any point over here is a solution to this inequality. All right, let's look at our next slide. Grab the mouse. Oh, looks like that's it. Let's double check that. Yep. All right, so it says your worksheet is 5.6 today, but actually your assignment is a different worksheet that you'll get in class, and there's also a link to it on Schoology. If you have any questions, shoot me an email and I can help you that way. All right, good luck.